In this episode, we take a look at what it takes to run one of our favorite sites, Stack Overflow. Hi, and welcome to SkellyCode.com. My name is Christoph Limpelaer, and in this episode, I'm joined by Nick Craver, who is a developer, site reliability engineer, system administrator, database administrator, and the list goes on. So obviously, he's touched a lot of the different parts that have to do with the Stack Overflow environment. And he's also written a number of excellent posts that talk about the hardware, the architecture, as well as the software powering the extremely popular websites that many of us use on a weekly, if not daily basis. And those blog posts are also in large part what inspired me to do this episode, which is good because that way you can go back and reference those blog posts and see what we're talking about in there. And we'll also talk about some things that are not covered in there just yet, but Nick does have a Trello board where you can go and upvote or vote for the topics that you'd like to see him write about. So definitely check those out. I'll be sure to add links in the description to help you find those. I'm really excited to get started, but I'm also very excited to tell you about two of my sponsors who are making this show possible, Hired and Rollbar. Hired is your replacement for pushy recruiters who try to sell you on jobs that you don't actually want. With Hired, you can find full-time or contract opportunities, and you can complete an application, and then top employers apply to hire you with personalized interview requests, as well as upfront salary information. You can go to SkellyCode.com/hired and earn a $2,000 hiring bonus, which is double the normal amount. You can also check out SkellyCode.com/rollbar to get a free 90 days account, so you can plug in error tracking to any of your applications in 5 minutes and start seeing errors in real time, as well as receiving important notifications in an orderly fashion instead of getting spammed in your inbox, which we all hate. Now, we will be talking about logging and monitoring throughout the episode, but I honestly wouldn't be surprised if Nick will agree with me when I say that getting this kind of visibility in your application and even in the infrastructure is super important. So do check that out. Hey, Nick, thanks so much for being here. I really appreciate it.
Hey, nice being here.
So I know I follow you on Twitter and you talk a little bit about what's going on in your life from time to time, but I know that you recently moved from a different house. So I really appreciate you taking the time to do this because I know that moving can be a very stressful experience and it was relatively soon. So I really appreciate you taking the time to do this.
No problem.
So I don't want to put words in your mouth, and I want to check with you and see what you think about that statement I made in the introduction of having error logging or any kind of visibility in the application itself, maybe stack traces or performance issues and things like that. How important is that really when we're talking about small scale or even large scale applications?
Oh, you got to have it. And it's so easy to get, right? There's a lot of third-party vendors. There's a lot of open source to be able to do that sort of stuff. And whether you're improving, which means you have to measure before to see what you're improving after, or what did you do? You just kind of spun your wheels, or did you make an impact? The other is knowing what went wrong after the fact, or even, being on the edge of something before it happens, right? Having the ability to see something before you go down is a whole lot more valuable than what went wrong afterwards, right? The monitoring side usually eliminates a lot of the error side if you're doing it correctly.
Yeah, absolutely agree. And I used to think that it was really just for larger applications or applications that had any amount of traffic. But to be honest with you, I kind of look at all that stuff now, whether it's a small application with very little traffic or even bigger applications, because seeing the kinds of errors that you don't expect or don't usually see unless you have some kind of notification system can really help you debug your own development process. Like maybe you didn't understand why this happened or why this triggered, but you can look into the stack and see, hey, this is the kind of query that triggers it, or this is where the bottleneck's coming from and things like that. So I absolutely agree. Perfect. Well, hey, Nick, I really want to talk about some of these Stack Overflow technical details, but I also want to get to know you a little bit better, just to know where your passion comes from, because you spend so much time writing about these things and we can really see the passion coming through it. But where does that passion come from? How did you get started?
I guess I've been doing IT of some sort since I was about 14 or so for doctors' offices and hospitals, networking, setting up the Quake servers, various, productive or non-productive things. And then my grandfather before that really got me into computers, right? That was his thing. He worked at AT&T, Lucent, Bell Labs, that kind of technology. And he got me started early on. And it was just an interest that, my parents, whatever you're interested in, let's foster that. And it went from there pretty much. I started from into college. I did CSC, ECE type stuff. that didn't really learn much in college. I consider myself a self-learner like most people in our industry, right? That's not uncommon at all. And then I worked for co-op for GSK for a little while, for a couple of years, went back as a contractor because they cut my hours short on the co-op. I wanted to take, more than 28 a semester. They're like, no, you can't do that. So I don't want to stay another semester. So to finish up, they turned me to a contractor, and that worked out well. And then, contractor for a while, started at long-term at some medical clinical research type stuff, building .NET databases, Oracle and stuff back then. And now Stack Overflow, which I worked, one of those places I worked at was with Jeff Atwood and Jared Dixon as well. So I'd actually known them before Stack Overflow, which probably helped.
I'm sure it helped a little bit. Yes, I was actually that's going to be one of my other questions, how you got this job. And I wanted to go back to one of the things you said, as well as one of the things I read that you posted, which was when you were going through your education, you felt like the current curriculum was 5 years or more behind the current technological times, I guess I could call it. And that's frankly why I actually started Skelly Code, this podcast, because I felt like it was the exact same thing. We were learning things that I just did not feel would give me a competitive edge in the current market. And so that's why I started this and started talking to people like you. And I think that's one of the really good ways to go about it, is looking at what companies like Stack Overflow are using and things like that, comparing it to what you're currently learning. And if that's the kind of career that you're interested in, maybe looking at some other options to learn on the side and be a self learner as well. So really interesting story there. But in any case, so you said that you knew Jeff Atwood and some of the other people at the company. Were you one of the very early employees there?
No, I was actually later. Jeff Atwood contacted me after I was the top user on Stack Overflow for a year. I was bored at my current job, right? It was a validated system. It's not to say you weren't working, but you couldn't make a big impact. You can't just go refactor this, which is what developers love to do, right? You're an engineer. If it works perfectly, take it apart, put it back together again, right? That's our motto. And you couldn't improve anything without it being validated. So lots of red tape, lots of stuff in the way, which usually a lot of time to answer questions. So I was like, well, there's not a big JavaScript thing. JavaScript jQuery wasn't really well covered then. So I just went nuts on it and answered like 6,000 questions a year or something in that. And that was top rep on Stack Overflow, just in spare time kind of thing. And that actually made Atwood take notice of what I was doing, I guess. And then I got hired and did no JavaScript whatsoever. So we don't, one of the things we look for, right, is ability. It's not for, do you know this code? Do you know this language? Do you know this platform? That's stuff you learn. It's hard to interview for, though, right? How well do you learn versus what do you know now? So it's interesting. We have that problem. I think everyone else does too. How do you
find that out? What are some of the interview techniques that you use?
You just keep adjusting your interview process, right? No one's got it down. We interview, we have multiple layers of the interviews. We say, okay, from an easy problem to a sanity check of, does this person have the criteria we need in terms of like, can they develop code? Can they analyze, given this requirements, can you interpret those, that kind of stuff? Then can you pass that type of interview versus a very hard problem, right? A specific coding issue, and usually whatever language you want. Because again, language doesn't matter, right? So you're trying to find an IDE that works for you or an online doc that works for you, and then we'll compile it or see it. And it's more about how you write the code than the actual thing, right? Do you consider this a problem? Are you thinking of the edge cases on the way through? Or are you just starting writing, which some people can do, right? Very advanced coders right off the top of your head writing it. In my experience, most of your time spending programming doesn't involve a keyboard, right? And most of my time doesn't involve a keyboard, and for better or worse, but it ends up with a better system, right? A lot more brain power than fingers should be involved.
Most of the time involves Googling and going on Stack Overflow, right?
Yes.
Maybe not most of it, but a good bit of it, I'm sure. Are you guys actually, now that you're working at Stack Overflow, and you've been working for how long?
About 6 years now. I started in January 2010.
Is that something that's internally promoted to go on Stack Overflow and continue answering questions? Is that something you still do on your spare time, or how does that work?
It's spare time. We're not paid to do it necessarily, but if we're debugging a problem, we encounter a problem, then yeah, we're encouraged to post it. If we run into problems, we post them. Stack Overflow is, for our intents and purposes, a bootstrap device as well. If we encounter, you see this a lot on server fault as well, which is the sysadmin side of things. So when we encounter issues with HAProxy or this weird thing with transaction buffers down in Linux in a deep, dark subsystem no one knows for the past 20 years, then we'll ask. And hopefully we get an industry expert that answers it. And then if we find a question that we think we would answer, we would self-answer it, right? Something we wish had been there, then we'll try and leave a public artifact of it. I think a lot of people, especially the engineering side of the company, is the primary consumer of our product, right? Our sites. Mm-hmm. And helping the next person is really important. And that's kind of like down to in the blood of everyone here, which is really cool to work around. That's never a company I've been a part of, that investment.
The other interesting thing that I've noticed, and this was from looking at different profiles like Twitter or your blog or any other profile you have, is you actually had different titles depending on which platform I was on. So in one of them, you were saying that you're a DBA or database administrator, and the other one a site reliability engineer, and the other one a developer. Is that because you're involved in different parts of the application? Do you switch jobs from time to time just to try different things, or what? How's that work?
I'm an oddball. I don't really have a role so much at the company. I hop around as to what's needed, whether it be a fire or to help out. This meetings week has been exceptional. This is my 22nd time slot meeting this week. Other times, you yank into Hangouts all day. Hey, Nick, how do you do this? How do you figure out this? And it may be how this system connects to the other system. I think my main role is knowing how all the pieces fit together and what things to consider when we're designing or speccing something out. I'm usually pulled in to help do that, right? If it's SQL, I'm the closest thing we have to a DBA. So I will tune SQL, we'll upgrade SQL. Greg Bray and George Beach are my partners in crime. They're on the SRE side. Right, they'll help test the SQL upgrades. We work with Microsoft ahead of time, right? We're in the TAP programs. There's an old blog post you can see on why we run 2014 CTP2 in production. Well, before RC releases, right? And why it's beneficial to us and you that we do that. Less bugs hitting RTM is better for everyone, right? The other things like developer, some days I'll write JavaScript. Some days we'll program a network switch. It's a hop around. The closest person to my role at Stack Overflow is my buddy Jeff Daugus. He's also straddles multiple teams, right? So we have an SRE team. The sysadmin team takes care of the offices. That's our delineation, the company infrastructure. And then the SRE team takes care of the sites, the data center side of things. And developer is obviously Stack Overflow, the code base, careers/jobs that you see on Stack Overflow. You'll see integrated. I need to do a blog post on that. How we internally proxy it to make you think it's a single application is a little fun. It was a very quick way to ship it, an existing thing. So that's kind of each day you may wear 3 or 4 hats, and it's fun. I love doing 100 things a day. Some people go mad. I can't just watch TV, right? I've got to have the laptop. I've got to be coding while a movie's on. My wife loves that. So it sounds like you've got different responsibilities, and by you, I mean the SRE team, the DBA team, things like that. They have their own responsibility, right? But how do you, or are you the person in the middle that helps the communication between the two parties? Or how do you guys make sure that you don't have those silos where information gets trapped, but you can have that communication flowing? I help that a lot. I'm by no means the only person doing that. If you need an SRE in something, you yank an SRE in. If you need if you don't know who to contact, you just ping the team lead and say, hey, I need somebody. And it's related to this. It's related to email. It's related to hosting, or it's related to we need to do network bandwidth. Or, for example, yesterday morning or 2 days ago, we had a Providence as an internal API. Jason Punion's written about this. He works a lot on this. He tells me when it's broken. If the monitoring hasn't already gone off, Jason's gone off. And it's 200 times worse because of a patch we did the night before. Yeah, and then we rebooted and it went away, and I'm furious because I can't figure out what it was, right? Reboot solving is infuriating. So that kind of stuff is, they know who to grab, right? And the team lead will know if you don't, right? You just drop in the chat room. Each team has a chat room. We use our own chat software. There are internal protected rooms people just can't see. There's a wheel of blame. We optimize that, right? If something goes wrong, you just say, not my fault. It'll pick somebody. You move on. We don't care who broke it. That kind of stuff is very handy for DevOps, right? Just drop in the room and grab somebody. Either you have a point of contact, or you can very quickly get one for a project. And I think all companies struggle with this, right? How do you get the right people involved early on a project, whether it be decision makers or technical expertise or whatever knowledge you need? And I think we do a pretty good job of that. We're always trying to get better at it, right?
How did you get such a broad knowledge and skills? Was there a point in time where you did have a more focus on a specific area and you learned it inside and out, and then you moved on to a different topic and learned that inside and out? Or is it just always been just trying different things, moving from one topic to another? on a daily basis or things like that. Does that make sense?
Yeah, more of the latter. I see something and I'm curious. I'm a big believer of like, if you see something and you say, I wish I knew how that worked. Well, you can. It's the internet. You can learn anything you want with a quick Google search, right? Google gets my money's worth, right? That's all my internet space for Google. That's what you're doing all day. We're all learning at this, right? Sysadmin, I did some roles at previous companies, pure sysadmin. Other companies were pure developer. Other places, I was the only person running SQL. Some other places didn't have SQL. They're all in Oracle with DBAs that you really wanted to poke with sharp sticks, right? When they stripped out all your vowels from the column names, that was our favorite. They had a program to do that. There's a special place in hell for those people. So that kind of stuff, you just learn as you go, right? Doing multiple things at once, I think helps me learn that. But I think you got to be learning all the time. I have fun doing that. And so it pays off work-wise, I suppose. Some people, at the end of the day, you want to play a game, or if you want to read a book, do what makes you happy. It happens to be that aligns close to what I do. I really am in a dream job, right? Which is extremely lucky. I hope everyone else gets to do that in their life.
Absolutely, and unfortunately, I don't think that's the case. But it's a very difficult thing to find, and sometimes I think luck has a lot to do with it. So definitely very happy for you. That's awesome.
Yeah, it's circumstance. A lot of it's circumstance. I had good ones.
I can say the same thing. I absolutely love where I am today, and I'm loving what I do at Linux Academy and also for Skelly Code. I can say the same thing. It's fantastic. It's amazing. In fact, I spend a little bit too much time on the computer, to be honest with you. I've been trying to have a little bit more of a work-life balance. I know that's one of the topics that you might be writing about in the future based off of the Trello board, but it's definitely something that's hard to do because when you have multiple passions, where do you draw the line? How do you allocate the time and things like that? So that's definitely an interesting topic as well. One of my longtime sponsors is Rollbar, and they've been a longtime sponsor because their service is something that everyone listening to this right now could benefit from using. The founder of Circle CI recently recorded this testimonial. Listen to this.
The most important thing in delivering things quickly to your customers is having a level of confidence that the code works. And you can't perfectly test something before it goes out. You can't perfectly validate it. You're going to put it in front of customers and something weird and new is going to happen. And you have to know when that goes wrong. You have to have something like Rollbar to tell you something just went wrong and to alert you about it immediately. Otherwise, you would just be paralyzed by fear. You'd be unable to ship anything because you wouldn't know when it would go wrong and what the downsides would be.
Now, I know a lot of developers who are not using any kind of error tracking, and frankly, I can't understand why. When it takes 5 minutes to implement something which could save you tens of thousands of dollars and hundreds of hours of debugging, there really is no choice to make. Get 90 days free at scalarcode.com/rollbar. That's ROLLBAR. Let's move on to a little bit more of the technical details where in some of those blog posts, you cover the architecture and the hardware and things like that. But if somebody has not read those posts, can you give us a quick overview of what the architecture is and how you run in the environment and things like that?
Sure. We're primarily, I guess it's a Lisp stack or whatever you want to call it. It's Windows, IIS, SQL, .NET code, mostly C# for our programs. Someone's trying to pitch F#. Good luck to them. We'll battle it out. There's some good uses, right? There are certain parts of the infrastructure that are interesting. Some of them are as vanilla as possible, right? We're using HAProxy with not exotic configs. George Beach is a good source. He blogs actual configs that we have with this. We have Elasticsearch for our search on the background, running on Linux, 3-node cluster. SQL Server is there's a primary server for Stack Overflow and a primary server for everything else on the network. And I detail in the post like what the split of those databases is. There's like 5 on this one and 300 or 400 on the other one. I think it's like 395 right now. And those each have 2 replicas. One in the New York data center, so we have redundancy there, and then over in Colorado we only have 1. And that more has to do with cluster quorum dynamics than cost. 2 and 2, usually not so good for a quorum. And then the other bits we have aren't really that interesting. We open source the things we think that are, right? Our ORM layer like Dapper for accessing SQL from C#, .NET, any .NET platform is really micro ORM for efficiency. That's what our big thing is. Stack Exchange.Redis is the official Redis or Azure cache client, which is Redis underneath. That kind of stuff. we have below. There's not a whole lot. We try and be boring. Boring is stable. Boring is scalable. The simpler something is, the higher it scales. And I think you'll see a lot of that in our infrastructure. On top of the web servers, so there's 9 web servers running production. We can run on one. This is entirely for redundancy, rolling builds. We've run on one. I think I mentioned there accidentally several times. It's fun every time for some definition of fun. And there's 2 more web servers at the end, which is dev, meta. They run a different config. But the 9 are homogeneous web servers. Exact same config. It makes it easier to deploy, easier to, any sysadmin running a lot of boxes. You want plain, boring, simple. And then behind that, there are 3 service boxes right now. One of the cool things we might be doing on those is buying some new ones and sticking GPUs into them. I can go into that if you want. Those run background services like that Providence thing I was telling you about. It just hits Redis back and forth, very, very low latency connections. If it takes over 10 milliseconds, we alert on it. Right, it's very, very low threshold. The 99 percentile of those requests is 1 millisecond. Right, that's kind of level of performance we want. And they run things like re-indexing related posts you see on the side of Stack Overflow. Right, this question is related to another one. Well, new ones pop up over time. We don't run that live. We background do it, and the indexing of the sites themselves runs on that background tier.
And you were saying GPUs. Why the GPUs? So
GPUs, when you go to Stack Overflow and you say, I want Java questions or C# questions, right? Tags are a big part of our thing. And it's not just tags. A lot of people have blogged about this, and we do snicker a little bit, I'll be honest, because they're solving the simple problem of what's a C#. Well, you can pre-compute that, right? In the most common sort. The complicated ones are, what are the C# ones that aren't closed, but we're open between these 2 dates with 3 duplicates and like all this different criteria, right? And exclude this list by this person. And our system also supports all of these scenarios, some of which are computationally expensive. So Mark Gravel has done a ton of work to put this so you have like a binary matrix in memory. And now we can fit all of Stack Overflow, I think in 700 megabytes. It's 1.7 gigs now.
Wow.
The entire network in that. And we can look at the tag engine. And we're doing that in memory on a CPU. Well, we figured out a GPU lines up to this, right? A GPU, if you take a simple task and scale it across thousands of cores, it's an excellent use case. That is the greatest use case. So with GTX 1080s, which have 8 gig of RAM on them now, the old ones were 4 gig, right, on those consumer cards. We can take a consumer graphics card for $700 and make our tag engine roughly 10 to 20 times faster than our CPU rewrite.
Wow.
And we can fit the whole network in card memory now and grow a little bit. The alternative before was taking a GPU, enterprise GPU is $5,000, and for about 35 to 40% more performance. Well, that's an easy cost trade-off, right? And we can stick 2 of these in the server, and it will be exactly like we have at home, right? I run 2 GTX 1080s, so does Mark, just for the tag engine. So it's a pretty cool thing. We're just trying to get the cards at this point. NVIDIA's got to limit a 2 per customer. Jerks.
Are you serious?
Yeah, that's why we can't get them. That's the entire holdup.
So how do you actually test that? Like, did you test it locally on your own computer and you did some performance benchmarking and then you theorized that, hey, if we scale it to this level, then it will help us by this amount and things like that?
So this came out of a mailing list Mark was on. We talked to someone and we said, okay, this actually seems like a thing we could do. And then we just looked into it. And we're like, yeah, we can build this ourselves. And we got him a GTX 1080 to try it on. Said, okay. And later we got him a second GTX 1080 to, try the active passive kind of thing we need in a server, right? And after that, we said, and at the same time we're doing this, after he got a GPU, and he's running on a 960 or something at this point, or 980 GTX, I think. At that point, we said, okay, this is viable. We have a working product. And we work with Dell and NVIDIA to run it in their labs. So we just hop on, run our workload, and we ran it in on all the hardware we have, the different server types. And we just, did performance numbers. We took all the load of Stack Overflow, we recorded it out, and we just hacked in some code, added some logging, and we replayed that load. Very, very simple when you control the whole stack, right? And then we said, yeah, this is actually viable. And then we bought some cards for local to do it, and I got the same thing, reproed his results, and now we just need to build a couple of Dell R730 servers. You can put some 2U graphics cards in.
If you set something like that up for production, how do you switch over to a new setup while ensuring that there's no downtime or any issues with the processing or anything like that? How do you guys do that?
So since there's 3 tag engine servers, we'll just take one out and fire it up. The tag engine itself just listens on a port and it runs whatever behind itself. So it may be in GPU mode or it may be in CPU mode. So we would just, add that server back to rotation. Now, the important thing is that our requests like this to Tag Engine on the background and even Elasticsearch don't go through the load balancer. They go direct. The app is aware of all the backend systems. That gives you a lot more insight into what's going on, what's healthy, what's unhealthy, how many requests it had, what timings it has, that kind of stuff. On the flip side, you don't get the logging from HAProxy. So those 1 millisecond requests I was talking about with Providence, they do go through HAProxy because it's easier to load balance across just some simple IIS pools. And also we get all of the logging coming out of HAProxy. We log every single hit to HAProxy.
Do you use anything else for logging, or is it really just going through HAProxy and pulling those logs from there?
So HAProxy has an output built in of syslog, and you can add whatever captures you want to that thing. So the applications are sending extra headers back, like your request grid. If you go to Stack Overflow right now and you look at your response headers, one will be a request grid. That grid, we can go find the log, that exact request, right? So those things will pass through, and it could be how much time was spent in IIS. You know, when I say in the blog post how many SQL queries we did, how long they took. These are the headers that come back from the app. And they get piped into the syslog that just gets shipped off to 2 SQL servers, one in New York, one in Colorado, and they each log independently. So syslog goes across the WAN from both places. We have a 10 gig MPLS between them. And it's not, we're talking like 5 megabit of traffic. It's not a huge volume of traffic to log this. And then we stick it in SQL. The process that sticks it in SQL makes other things possible, right? We can do whatever we want to at that point. So one of the cool things we have that we want to work on a rainy day is it sends every question view over to Redis via PubSub. And we have a process that listens for that and builds a queue of who's actively hitting the site so it can demonstrate it to like advertisers who would, like if you're posting a job on Stack Overflow, who would be seeing this thing? Nothing makes quite an impact as someone pulling up and say, look at the hits you could be getting right now. And look at the dots pop up on a map, right? Now we could actually do that for every web request we have. Although I think it would crash the browser, but we're going to find out.
You're going to find out.
Yeah, can we put 4,500 dots per second on a browser without killing it? I don't know. We'll figure it out.
So a lot of it is really just trial and error. See what works, see what goes faster, and things like that. Do you have any tips you can give for maybe smaller scale environments that are trying to implement this kind of detail where they can see all kinds of different relationships between calls, how long they take, where the errors come from? How do you set things like that up?
Get something that exists, right? A lot of the big companies build this stuff and they release it. There's Mini Profiler we build, right? That's not ported to .NET Core yet because there's a lot of things to do with that. That would be 4 episodes. And then there's Glimpse, which is ported to .NET Core by the Microsoft guys. They were bought by Microsoft. And it's a good tool, right? It's a little more overhead than we want at Stack Overflow. But long term, would we move to it instead of maintaining a profiler? Maybe. We're not against anything. We have loyalty to nothing. If there's a better option that comes along, move to it. And the cost of better includes the cost of moving, right? So when you analyze, is this a better option? Then yes, move included. Let's go to it, right? So things like Mini Profiler, I read a library called Exceptional that logs all of your errors to a central place, right? We take all of our apps all the errors from all the apps into one SQL central store, and that is read by OpsServer. So the teams can very easily say, here's all my apps, here's all my errors that I care about today. And that's not the only one. The exception list is another one. There's like 20 of these. Grab something that makes you fit. They're all a little different and they match whatever your approach is, right? Usually you can very easily plug this stuff in and just start looking. Even if you have Mini Profiler we like, and Glimpse is the same way. You see the number right on the page. So if you're looking at performance, nothing screams performance like, wow, why is this thing red and why did it take 90 milliseconds? Like this is insane, right? Or why did it take 9 seconds? Even if you just fire it up and say, oh, it's the file off disk that's slow. Whatever your case is, right? We thought this was cache, but it's reading every time. Usually there's so much low-hanging fruit. And the simplest thing you can do is grab something that pre-exists and plug it in. A lot of people trying to build it the first time. Don't do that. Take an existing tool and learn from it, if nothing else, for like an hour or a day or a week.
And then if you need something that is not offered by that tool, then you can maybe branch out and build your own things on top of that. But you can cover some of those basics with pre-existing tools, right?
Mm-hmm. Yeah, a lot of the times that stuff's built or almost what you want. And if it's almost what you want and it's open source, PRs or issues, it doesn't. People are like, PR is accepting. Okay, but at least file an issue and someone else might do a PR, right? The very bare minimum. I encourage people to file issues on something that doesn't work for you. Because when I build Mini Profiler and work on it, and I'm not the only one, Dapper or Stack Overflow Redis or any of these open source libraries, we're building them for us. We know our use case. There's some issues open for Redis clustering because we don't use it yet, right? I can't dog food this and with high confidence tell you it's good. But when we deploy a NuGet library, one of the advantages we have working here is that we dog food it on Stack Overflow. Every library we give you on NuGet is dog fooded, and it's published and hidden and dog fooded on Stack Overflow before we hit the go button on NuGet. There's a new build of Stack Exchange Redis for .NET Core out right now. It's just hidden. .605 is out there. And we're just making sure that it's rock solid with high load before that happens. If you have spin up concurrency issues, we'll find them really quick. That's one of Mark's benefits.
Speaking of those low-hanging fruits, let's say that you find something that takes way longer than it's supposed to take, and you figure out that, hey, this is what's causing it. How do you take the next step further in figuring out how to solve it? And for example, let's say that it's a database query that's just taking a little bit longer to respond for whatever reason. How do you open that up and figure out what's going on behind the scenes?
So there's two approaches. If you only know the area it's in, one of the things that this is why we build Mini Profiler this way, it's using statements. So if this chunk of code is taking too long, then you can put more concise, more granular usings to see exactly what it is, right? That'd be your first step usually, because we don't profile every single thing. We profile the big stuff and we're like, oh, we may need to go a layer down. If you know it's a database query, you take it out and you put it in SSMS, right? So if I go to the Stack Overflow homepage, one of the things Mini Profiler has, and I'm pretty sure Glimpse has this too, you see every SQL query and how long it took, including the parameters to easily copy, paste, run it in SSMS. First thing you want to do is repro any problem, right? And keep in mind that SSMS isn't always going to be accurate in terms of runtime. There's different things with plan cache and not hitting the same thing and not using SQL prepared statements. There's always things that affect it. There's a very good article I recommend anyone hitting this read. It's called Fast in SSMS, Slow in the Application. It's a very long, old article that details everything to do with this. I don't even remember who wrote it at this point, but it's a fantastic read. Every developer should go that if they're dealing with SQL. Should go read that. Those things, you find what it is. SQL 2016 adds some bits here, which are very handy. I don't know if you've seen live query plans. So you don't just see the query plan of where the cost was. You actually see it as it's running, which operations are in play. There's some overhead to doing it, but you're just using it when you're debugging, right? And it doesn't fundamentally change the shape of the plan or anything. So that kind of stuff. And then you see, do you need an index? And a lot of that, some of that's intuition, some of that's just experience, right? Mm-hmm. How does this behave? What is connecting? But the main thing is reproing, right? And including reproing more detail of the problem, right? It's this hash match join. That's slow because, so for example, one of the things that came from the app and was fine in SSMS, we're looking at it, we can't reproduce it. It was searching a bot detection based on an IP on the post table. And the reason you couldn't detect it is because it was a varchar passed from the app as a parameter rather than a car, which is in the database. And that was doing the conversion for every row it looked at in an unexpected way. And sometimes you don't see that stuff, right? But if you would have copied from Mini Profiler out and it was set to declare varchar at the top, we add the declare statements with the parameters for easy running. A lot of people do this. It's not special. That's very handy, right? The other thing that we do that's extremely handy, you have a gist of this. I'll put it to you so you can post it in the show notes.
Please, yeah.
What we do is we add a comment to every line of SQL that runs through our ORM, through Dapper. On the way in, we use caller member attributes, which say which file it came from, which line number it came from even, what method, all that kind of stuff. You can put in the SQL statement. So every SQL statement we have has like / that information, / like after the first select or something. After the first line, it's just a little regex to find where to put it because you can't start with that. It doesn't always come out of the monitoring tool on the other side. But that way you'd be like, look, I know exactly where this line of code is. I don't need to look. And including that doesn't only help the app. Say if you're in Glimpse, you're in Mini Profiler, you're in something like that, you can find this usually from that has the call stack, right? If you don't have that and you're from a DBA point of view, you're going, hey, who's screwing my database? Then that's very handy because the developer goes, yeah, that code sucks, right? And then they go fix it. This is the normal interaction. It helps other roles. So when I'm looking at anything, it's handy. And it's very simple to plug in. These are like a couple of extension methods. I'll grab that just real quick.
Please, yeah. So you're actually able to see so much information of what's going on at any point in time. And you can always go back and look at the logs and trace back to, hey, this interacted with this. This is what's going on here, and try and debug that information. That's brilliant.
It's anything you log. The more information you have, the better. If you're logging too much that it's noisy, that's a different problem. Most people don't have that problem. Alerts on tiny things are typically what people run into, but actually just having the raw information. People conflate with, oh, we shouldn't collect that with we shouldn't get an alert. No, you should scale back your alerting, but the actual, just having all the data points possible is good. Within reason. If you're filling up hard drives at 5 a minute, then it's probably not a good idea.
And you said you don't really necessarily look at the tiny details, but more of the overall picture of stats, like performance stats and things like that. You don't look at the tiny fractional numbers, but like a request or something like that. So is that how you reduce some of that noise, and you don't look at too many different logs and things like that?
Sometimes, at our scale, right? That's the kind of the area, or that's the granularity you're looking at, and then you go further down, right? So if we say, hey, we're getting, let's say for example, we're getting 500 API errors per hour now. Well, yeah, then I'm starting to look at individual requests and see what happened, right? Can I repro this in any way? And we capture each HTTP request that comes to us, not like the form data or anything. We explicitly start out passwords that never goes anywhere, right? But just the user agent, the time it hit, the route it hit, how many SQL queries ran, the time it took, that kind of detail goes in a database, in a clustered column store in SQL in particular, and we'll pipe it to Logstash or Elasticsearch directly soon. We have a 300 terabyte cluster for that. That kind of stuff's very handy because someone comes on Meta, which is our error reporting. Meta.Stack Overflow is like just talk about the site, bugs about the site, features, that kind of stuff. They'll say, hey, I can't log in. And we're like, okay, well, what was this person's flow, right? Did their IP change in the middle, or did they get kicked around? Or we're like, well, why did they get a 514, right? Or something like that in the middle. And that way, that usually, because the person who designed this was Jared Dixon, who said we should log this stuff in SQL. We said, Jared, you're an idiot. We'll never use that. Now, daily, it's used at least a dozen times, right? He was completely right. I'll admit it. And it's tremendously handy just to have that data. Very big. And I can pull those stats for blog posts, right? That's all you need.
Those are very useful and very impressive. I remember looking at some of those stats, I think from 2014 or something like that. And I was looking at the stats and I thought, okay, this is a month period. And then I read back the first paragraph right on top of that for some reason. And I saw, no, this is actually a 24-hour period. And they were just absolutely monstrous stats. So definitely check out those blog posts if you have not read them yet. I can't remember exactly which one it was, but I'll link all of those up to below the video. If you're looking for a new opportunity with top employers, don't go through the traditional stressful and time-consuming process. Instead, use Hired by going to scalycode.com/hired. They make the job search faster, focused, and stress-free. You complete a simple application, and over a 4-week time frame, you receive personalized interview requests with upfront salary information. Throughout the entire process, you have a dedicated talent advocate who provides you with unbiased career coaching so that you're on top of your game when talking to employers. Hired gives you access to 4,000 plus innovative employers, including big names like Facebook and smaller emerging startups. The size and type of company that you want to connect with is totally up to you. The best part, though, is that not only is it free for you to find your next job with Hired, but they'll actually pay you $2,000, which is double their normal hiring bonus, if you sign up through my link, scalycode.com/hired. So you actually mentioned Elasticsearch using with the database. And I saw this posted as a question on Trello, and I think this is a great question. How do you synchronize the data between the database and Elasticsearch when you're talking about massive amounts of data?
So there's a couple of tricks we use. One of the things was me and Sam Saffron way back in the day. He works with the Discourse on Atwood now. Don't blame him. He's in Australia time. That's brutal. So one of the things we found out was row version. It's a seldom used thing in SQL where you say, okay, this number, it looks like a date time. It's not a date time. It's nothing to do with date time. It's just an incrementing sequence of number when anything on that row changes, right? So, that looks appealing for deltas, right? If you could record the last one and then come back and get everything since it, I know which things have changed on that table, right? Which rows, whether they be new or altered. So it could be a post. So questions and answers are stored in the post table, right? They're both a type of post. There's other type of post, tag wikis and yada, yada. If those change, say the title changed or the text changed, the body changed, whatever it is, the score, right? Those get re-indexed. because their post number changes. So they go back into Elastic that way. So what the Elastic, those service boxes talked about, those three, they compete with for a Redis lock, and whoever gets it runs. And each of them compete on each site, right? So Stack Overflow runs every 30 seconds. Most other sites run every 5 minutes or 10 minutes for child metas, which are very, very seldom in terms of volume comparison. They're much lower traffic. So when you do an indexing pass, you go, okay, give me all the posts and other things. We index other stuff besides posts. Give me all the ones since this creation date. And the creation date just being a big integer, effectively, sequence number. Give me all the ones that updated since then, and it just loops through and indexes them, right? Very, very simple approach. And the key point is we store that document in Elastic itself. So Elastic maintains its state and where the position it's at. And so if we index New York and Colorado independently from their local SQL servers. So each one keeps going. So if we need to upgrade Colorado to a new version of Elastic, these clusters don't talk to each other, right? One of the mistakes I made in the dev local setup, which is a set of scripts we have to set up dev machines, it's all PowerShell based. It's like you click to open and you can hit a few keys to completely provision your machine. Visual Studio, the repos, the databases, the IS websites, the security certificates, everything installs, right? The VPN, it does all that stuff for you. And we've iterated and improved this over time. And I'm not the only one who's built that, by the way. So one of the dev local setup bits that we have, which is provisions all a developer machine, right? It was made to install Elasticsearch 2.0, but we ran into issues, which are documented on Elasticsearch's issue list by me. Some are spirited. The 1.0 has a nasty little default, which does multicast discovery. So one of the things that will be rolled from 2.0, which was my plan, back to 1x, which is or 171 or something in that script, 172, it does multicast discovery. So unfortunately, everyone in the office was forming one giant Elasticsearch cluster with their developer machines. Not a good side effect. That actually happened to Amazon early on. Everyone's customers saw each other's data. They had a lot of fun with that one. Oops, right?
Right.
So that kind of stuff is a little fun in terms of how you set it up. And the simplest way we have is go to your local SQL server, index your local stuff. And it self-recovers. The Elasticsearch indexing itself is called Project Cockroach. It's really hard to kill. We had to add some kill switches because it'll bounce between service boxes. It'll bounce between indexes. If this box is indexing Stack Overflow, the next two trying to take a lock will simply skip over it and go index the next site. So they're all racing to index 400 some databases. And if you want to recover the thing, you basically just delete the index and it will completely repopulate, right? It's just a very, very simple setup. And I've kind of open sourced a little bit of that in screenshots. We're using the Microsoft TPL data flow with HAS library to kind of balance the processor allocations there. Because one of the things we found is when we upgraded the web server, and there's a blog post on that. Actually, I don't think this is on my blog. I'll link you to blog.serverfault. There's an interesting post people might find called How We Upgrade a Live Data Center. This was during a blizzard for extra fun, because why not? We upgraded the web servers to higher power CPUs. It was time. They were 4 years old. They were running fine at 20%, but they said, hey, we should spend money this year for whatever reasons. We're like, okay. So one web server or one service box would kill the Elasticsearch cluster by sending things too fast at that point. So we had to back it off a little. We're hoping Elasticsearch 2.0 improves that. And honestly, if someone from Elasticsearch came to me and said, you're doing it wrong, it wouldn't surprise me at all. There's probably a lot on the table there, but it works. It works good enough out of the box with very little tuning. So we don't go super non-vanilla there,
Hey, you've mentioned Redis a couple of times now. I know you use Redis as a caching system, but you seem to use it for other things as well. Can you talk a little bit more about that?
Yeah. So there's two major points of Redis. One is the caching system. So there's a database in Redis as an integer, right? So that correlates to our site ID on a sites table in SQL. That's your one-to-one. Stack Overflow is site 1, super users 2, server faults 3. I may have those backwards, but that's that database in Redis, and that's our key space, right? And then you have prod or dev or local, and you have key space isolation. We don't typically need that anymore. It's a safety mechanism, just in case someone downloads a site setting, connects to their own place. We enforce that pretty hard. I don't think it'll happen, but when you store keys in there, there's a couple things we do. And Kevin Montrose has a good post on how we do it on meta.stack exchange. I can find that link for you too, about how we do L1, L2 caching, right? So L1 is HTTP cache in .NET, just in the local app pool. And then we have L2 is Redis. L3, it's not a transparent cache, right? People are like, oh, you read from SQL, store it. No, that never happens. We store it manually in Redis with this object, this protobuf encoded object, almost all the time. Some other smaller apps might use JSON or something, including in our infrastructure. But other than that, you're talking about going to an API or a database or a file or whatever it is, whatever the source of that data is, right? And sometimes you just want L1 cache. Sometimes you want L1, L2. Sometimes you just go to Redis, right? So for Redis, the things that would go direct would be like hash sets or anything with like kind of atomic operations. You get an integer, increment an integer. An example of this on Stack Overflow, on the top bar, you see your account, your reputation, your messages, that kind of stuff, how many are in your inbox. That's a directed to Redis. So even for a normal logged in user, you're talking about hitting it like 7 times per page load, and that's nothing. We can pipe 250,000 ops per second per server through Redis, and it's fine.
Wow.
It's an amazing piece of software. And we also use it for PubSub. So when you see a question list or a question itself, you see the score going up and down, right? The WebSockets that we have, that's using Redis. So we publish a message when an event happens on the web server through Redis, and the subscribers are the WebSocket servers listening on the 9 web servers. They're same user infrastructure. And then they're piping the WebSocket message out to you if you're subscribing to one of those channels, right? Whether it be the score on that particular question, or say you're looking at the list of C# questions. So then you're seeing new ones come in, that kind of stuff. And Redis has downstream servers, currently called master slave. That's a big thing. They may change that verbiage soon. But the child servers in Redis down let us sync between data centers. So we have a master in New York, a replica in New York, and then 2 more replicas in Colorado. So it's a 4-slave down kind of thing. And there's blog posts I have with pictures of that NOP server, right? So that kind of stuff lets us, PubSub actually travels through there. So a side benefit we never designed, but works out well, is we could run WebSockets out of Colorado. Or we could spin up a Redis replica in Amazon or Azure or the North Pole and do WebSockets out of there. Because WebSockets are actually something we're working on right now. They're problematic at our scale. Most people don't do WebSockets at our scale. And if someone does, please let them talk to me, because we have so many issues with scaling those out. Google, Gmail, Facebook, people assume these guys use WebSockets. They don't.
What do they use?
It's just polling, long polling, the old tech, concurrent connections, persistent connections. Like that's a file handle or 2 through a load balancer, right? Front side, back side. And you're talking about, so right now in Stack Overflow, it's late on a Friday, so there's not a lot going on right now, but we have a constant monitor of WebSocket connections going through our infrastructure. And right now we have 455,000 concurrent connections through one IP, basically, on the load balancer. Oh. And that opens up 1.58 million file handles. And we easily get 100,000 more than this during the day, And what we're trying to do is say, okay, can we use shared workers, right? Can we use some new stuff to say, if you have 10 Stack Overflow tabs open, can we condense that down to 1, right? So we've got that working, but it requires an extra web request because of the way the shared worker has to be initialized with a URL path. Advertisers ruin this for everybody. So since they've locked that down, we have to maybe do it with an iframe that creates the image, which would allow us cross-domain post message. So now we can condense even like DBA.Stack Exchange, Stack Overflow server, all those down to one website connection for all the sites. Well, that's pretty appealing, right? And if we do that, that means that 455,000, we think based on numbers, will drop to about 100,000 less than that. That means we can enable WebSockets for more people. On Stack Overflow, you actually have to have 30 reputation to get them right now because of these technical limitations. So as we roll that down, it scales up who can you access them. So we're working on that. That's an active little thing we're playing with.
Just in case somebody's listening who doesn't really know what WebSockets are, can you explain quickly what they are and how we can use them?
Sure. So instead of a really big HTTP connection that has headers and footer, all this orchestration around it, WebSockets are very, very lightweight. Simple connection and upgrade, and it's like 0 load to keep the thing open, except for these sockets and file handles. So for us to send you a message after the fact is very, very, very cheap. Versus like someone polling every 5 minutes for a new message. It's instant. We've pushed you exactly when it happened. And the other is it's far less load overall for infrastructure. So very handy, but scale issues.
Just to check real quick, how are you on time?
I'm good till about 3:30.
Okay, cool. Awesome. I know we started a little bit later with the audio, trying to fix the audio and things like that. So I want to make sure we're good to go.
Okay.
What have been some of the biggest mistakes that you guys have made? I know we've talked about some of the challenges you currently have, some of the things you've overcome, but can you think of any major mistakes that you guys have made, looking back, you shouldn't have made?
On the technical side?
Yes.
I don't think we've had that many. We do a lot of research, and what we do is we make the best decision we can with the data available at the time. Redis seemed like a good idea at the time. Actually, Kevin answers this on Meta as well. Why did we choose it? Like, well, I did some research. It seemed like a good idea, and it's worked out pretty well. If something comes along that works out better, we'll change our mind, right? That's how brains are supposed to work. So, and we go with that, right? We can adapt over time. We've obviously done some fat finger mistakes, right? When we were upgrading the data center in Denver back in June, one of the last things I did was I changed the buffers for the transmit and receive on the NICs. One of the last ones, George did this tuning as well, and rebooted the tier. Well, it turns out NY is really close to CO on the keyboard. Well, not really, but that's what I typed. And I rebooted the production web tier all at once, right? Now, luckily, it rolled a little bit, and people only noticed for like 10 seconds, but I was like, oops, right? Rebooted 9 web servers, shouldn't have to. Restart computer, dangerous command. Even more dangerous if you don't give it an argument, right? You just reboot your laptop. I've done that. Things in terms of we've lost data before, right? One was not our fault. Sam Saffron, this was before me, did a very good job of cleaning up. There's a Channel 9, there's a, what is the This American Life, Developers Life podcast? There's a podcast on this where power lost on a data center, took a server hard down, and he kind of stitched together everything he could back from it. The other one was when we were moving data centers to SQL, moving both data centers and data from SQL 2008 to 2012 at the time. We lost 5 minutes of database data for one database. One of the T logs wasn't restored correctly. So I feel bad about that, but there was only 3 questions. If that's all we ever lose, we're doing good, right?
That is pretty good.
We've lost data on like internal systems before. We tried Cassandra for a while. This was an experimental phase, right? They were testing the crap out of it for the data team. Now they're using Redis too for like hundreds of gigs of data in one data set. They were using Cassandra. It lost power hard. Someone in our data center in New York, not in our team, the data center people, plugged 2 AB feeds into the same UPS system. I could go over how that's a bad idea, but hopefully it's pretty apparent. And then one circuit failure took out all the feeds, right?
Ouch.
So we were very happy that they did that. And then we moved shortly after. Luckily, that was already in progress. And then one of the Logstash upgrades went badly on 2.0. Luckily, we were like, okay, let's just force it, and we just tossed the data, right? And that's okay. That's not user data. That's just some log stuff behind the scenes. It was more of duplicate replication stuff. I don't think we've had that many failures, right, in terms of like big stuff that's gone wrong. We've had technology failing us, and I think we've done a pretty good job of bringing it back online, which is always fun, right? Fighting fires is a little bit of fun. But we've been lucky to some degree in that.
How do you protect against some of those power outages, since it is a very scary thing and it does cause damage? How do you protect against stuff like that?
There's a couple of things. There's 2 things we learned from the Cassandra failure. There's 3 things. They don't validate their time types or integer types to some degree. That the wire type's not validated when it restores, which is a very scary thing, which is why we actually moved off. We broke Elastic before that, so they shouldn't feel that bad. And then, we learn what went wrong, and you correct for it, right? Those machines also had cheaper SSDs, the Samsung 940 series at that time, 950 now. They don't have capacitors in them. The 950 or 965, the DC versions are the higher end enterprise supercap versions. And now we just use Intel SSDs and everything. Of anything that can't be lost, we put Intel SSDs in it. Power outages don't lose the data, right? People have this, it's weird. I don't understand it. I mean, I get where the confusion comes from, I guess. They say, hey, I've got 10 servers. I'm writing in Quorum. There's no way I'm going to lose data. I'm like, let me tell you why that doesn't work. Because you have all the data going through the system at the same time, right? You're in the network, you're in the server, and you're down the RAID controller, maybe, and then you're going to shift the disk. And you're going through that same DIM buffer with roughly the same commit from the same query at the same time on all the servers because you blasted it out to 8 at once, right? So it's not like inconceivable that all our DIM buffers had roughly the same thing in them when they lost power. It's like server quorum doesn't actually solve this issue. That's not a good thing to think. We learned that. We learned to really look under the floor and see where the cables are connected to the data center, that they go to 2 different panels. Yes, we did this in the new place. We're like, we just assumed, but now we'll look. So they're like, yeah, look, here's a blue cable, here's a red cable. They go that way. We're assuming there was a big loop back over here. So that kind of stuff, you just learn, right? You don't try and not make mistakes. I mean, you do, but you try and not make mistakes twice. If you fail 2 different ways, that's acceptable, but do it and move on, right? We do things a little risky. We do some things live. We do riskier things not live. If it's failing over a load balancer back and forth, if it's safe to do it, we'll do it. If it's a 99.99% chance we won't take something out, but it's a 3 times time saving, yeah, we'll do it that way versus the 100% safe way, although a few things fit that description.
What about non-technical issues? Since you asked, it kind of makes me wonder if there was anything you had in mind to say.
We've internally built some things that just didn't work out, right? We learned, and the same thing, we learned and we improved our process. We need to show this to people earlier. We thought we had a good idea for X and it wasn't a good idea. We rewrote the user profile. It took a long time one time because it got passed around and I was like, And then it turns out the users were like, ugh, right? So it was like, no, we should have been working on this. And now we're doing something that's got a lot more. Now we're going to the community way earlier, right? So that's kind of the stuff we're improving, including internally, right? As I get the right people in the call earlier, every company can get better at that. We're one of them, right? So again, just don't keep screwing up the same way. That's when you need to have a conversation, right? Like people don't get fired for screwing up here. You might get fired for screwing up the same way repeatedly, but we don't have that problem. You hit something and you're like, never going to do that again.
I feel like that's a pretty good note to end on, actually, unless you have anything else that you want to add or you can think of that we haven't covered yet. No,
if people have follow-up questions and all, they can certainly ping me. I mean, Twitter's good for short conversations, but I encourage people to go vote on that board you already pitched out, which is now that as soon as I get done wiring this place, I'm looking forward to coding again at night. The family's been sick one way or another for the past 3 weeks.
You were telling me what you were wiring. You've got the wireless stuff coming in. What else are you doing?
I can show you some of it. Let me see if I can reach over here. Oh, headset's going off. So the first 2 pieces of gear have arrived. I think there might be a USG on my doorstep. If that's so, I'm going to bring it up here. Amazon. I love those delivery notifications. Out for delivery. It's the best words on earth, isn't it? Oh, delivered. It's somewhere on my front porch. Okay. So these are the Ubiquiti access points. So I've got recommendations from people online and people here. They're like enterprise grade, right? Campuses, that kind of stuff. They make these access points because they look flat. They're not flat. They're like little half domes, like a smoke detector, right? Blue ring means you're going. Red means you're down. You just plug it in and it works, right? They don't. You need a network engineer background to configure this stuff. Luckily, I happen to have one. And you can do it cheaply, right? A lot of these enterprise deployments, campus deployments, education deployments, they take lots of equipment, right? You're talking like $20,000, $50,000 in hardware. If we buy a switch for work, like a 10 gig 48 port switch, you're talking like a $9,000 purchase, right? For the contract agreement, for like support for 4 years, that kind of stuff. Well, this access point, like Amazon, this is a 1.7 gig access points, right? For the these are 450 on the 2.4 and the rest on the 5, and you can get you can put one of these. Hopefully, 2 will cover the house, but you're talking about PoE, and they're $130. You think about a top end router right now is like over $400 on Amazon. So you can buy 2 of these with the injectors and run the controller, and you're cheaper than that. And you've got 2 access points, which is way better than any central router that can only cover an area, right? So I'm really hopeful about this stuff. I've got a lot of recommendations. They said, I used to live across the street from a park, and I couldn't get Wi-Fi. So I would just dial into home and crank up the wattage, and then I had good Wi-Fi across the street. And I was like, okay. So we moved into next to our best friends. Just beautiful. Nice. I recommend that to anybody. It's been great. I'm going to point a dish in the attic down at the woods down there we've cleared out to cook out. See if we can get good Wi-Fi about 400 feet away.
Nice.
I don't know. I'll report back, see how that works out. But I'm hopeful. I'm waiting for a controller key to arrive tomorrow. But I'm going to go in the attic on a 94-degree day because maybe not. maybe in the morning.
Not. Yeah, maybe in the morning.
I need to run some cable. Those RVU TVs I told you about, they require a cable connection, unfortunately. They won't run off the wireless, even though it's like 802.11 AC. So it's weird.
That's weird. Yeah. And I know you got some other hardware as well. I think you just built a new PC and you were mentioning the 1080s.
Mm-hmm. And the PC build, by the way, I keep on the website. There's a desktop build link up top.
Oh, cool.
That has, because people are curious, like just what's in there. I need to do a blog post on the Office. A lot of people have asked for of just what gear I have, which because I do take a lot of research when I order my stuff, and some of it doesn't work out. And I can tell you, like this treadmill, it's really good. I wish the connection on the back wasn't a DB15. Like it's a like a vest support type thing. And so is the Z5500s. So extending it's actually a pain in the butt because it's not the same wiring pattern as a monitor extension cable. You have to have a different one, right? So the treadmill is good, but like the up down buttons, you can't hold it. You have to press it for every 0.10 miles an hour. So it's like, that's annoying, right? But then I figured out I can hook it to Bluetooth and I control it on my desktop. I now click to start my treadmill, right? So if I just click right here at like 2.5 miles an hour,
nice.
You'll hear that beep starting and then it'll crank up. And that way, if I'm moving or stopping, I can actually fully automate the thing. I'm putting an API in this guy.
I'm surprised you didn't use it during the episode. You could have done some cardio.
I don't know if it's good for audio though, right?
Probably not.
So that kind of stuff I'm looking forward to. I'm trying to automate this house, and I'll tweet about it. I asked yesterday, I'm like, do people care, or I'll just shut up and work? But
I like it. It's interesting. I actually just finished my own build a couple of weeks ago. I didn't end up getting the 1080. I got a 1070 instead, which is still a beast. I mean, it's not quite as good, but it's still a beast. I love it, man. I've been running some games I don't usually play just to do some benchmarking, seeing the frames per second and things like that. But also I got an M.2 Samsung SSD, and that thing is lightning fast. So I've been having a lot of fun benchmarking all that stuff. So I might actually do a blog post as well about it. That's always interesting to learn about.
If you need any, there's a tweet stream somewhere I have of all the benchmarks and stuff. If any of that helps you as a point of reference for cool. Like what stuff I'm getting.
Yeah, I'm curious to see how you benchmark actually.
What crystal mark on the disks, right? I actually have one that seems to be crossing into one lane territory. I'm not really sure why. I'm not using the SSD much right now. What I want to order is they have 1 terabyte M2s coming out. Nice. So the thing is the new M2s, the 90 the SM961 are the new beasts. They're 1 terabyte versions, and they're 3.2 gigabyte per second read and like 1.8 write out. They're insane, right? Here's the thing. They're PCI 3.0 times 4, right? The theoretical of that is on the giga transactions per second equals out to about 3.9 gigabytes per second max theoretical, right? So how many M.2 SSDs are there? From like a couple months ago, there's like 10 out, and we've already maxed out another connector. So people are mocking PCI 4, saying we don't need that. We don't need the wattage in the card. Turns out the wattage in the card isn't even a thing. That was misreported by everybody. And somebody double checked me on that the other day, and they said, I don't think that's actually coming out. And it turns out the PCI working group just on August 24th came out and clarified, and they said, hey, that still doesn't work. Here's the SM961 link. You can get them from like Australia. I don't know. They're OME kind of things. OEM, sorry. But those like, guys.
Here I see $700 AUDs, not USDs.
Yeah, and the price on them is like not that expensive. They're the 3D NAND. They're cheaper to make. But you're saying 3 gigasecond read and 1100. Oh wait, that's the PMX. Here, 3.2 gigabyte per second read, 1.8 gigabyte per second write. And you're taking it out of a connector that only maxed out at 3.9. So PCI 4.0 doubles it, right? Gotcha. So now you can put an M2 that's got room to grow. So the connector isn't necessarily being outgrown because the bus on it's going up. Whereas SATA, you're locked in, right? Plus you have that long command queue crap.
The problem I had was when I put it in the top slot on the motherboard, it shut down a bunch of the SATA ports. And so I didn't have enough to run RAID for my other SSDs. And so I had to move that down. And I should have read the manual a little bit closer, but I don't know why. I thought it would be the inverse.
you have to. And that's the reason I build with the E-series processors. So like the Broadwell E or whatever. whichever series you want to go with. Now, you should have Skylake eventually coming out. They usually lag like a year. So that's the trade-off. You wait a year for that architecture, right? But they have 40 lanes. They're like Xeons in the lane count, whereas Skylake has 16.
Yeah.
And then you only have effectively 4 lanes down to the other 20. So when you see Skylake listed as having 36, there's only 16 on the proc, and then the other 4 out of the 20 on the proc, say another 4 worth, the DME, it's called the DME, connects down to like the North Bridge, and it has 20. But realistically, you're not going to populate them all at once. So having like multipliers, not in practice, it's not really that bad. Mm-hmm. But it is something to keep in mind. I do a lot of research on this kind of stuff before I buy it. But even when I did mine, I didn't understand exactly how it would disable the bottom PCI port on the second card.
Yeah.
I don't think it's documented that well, honestly.
The compatibility with CPUs and motherboards is really weird. Like you said, they don't really have a whole lot of information about it, which is very odd to me. So I kind of just bought stuff and I was hoping it would work. And from what I read, I thought it would work, and I plugged it up. And it was just trial and error at that point, but it ended up working out. So I'm pretty satisfied with the build. It's a very nice build.
Yeah, that's all you got to be happy with, man.
In any case, I guess we could wrap up here.
Sure.
Thanks so much for doing this. I don't think you gave us your Twitter handler yet.
Oh, it's just Nick_Craver, because Jared_Dixon introduced me to Twitter. And now I blame him for that underscore for life.
And then your blog is nickcraver.com. Of course, I will link everything that you sent me on Google Hangouts here and more that you have. I'm actually looking at the deployment posts here, which I have not finished reading yet, but that's going to be very interesting. So anyway, Nick, I really appreciate you doing this episode again. I thank you so much for your time. If anyone has any questions, please check out his blog. There are comments on the blog articles as well, so you can ask questions there. I see a lot of people interacting there. And please leave a comment on scalarcode.com as well for Nick's episode. Thank you so much for coming out or for listening. And thank you, Nick, for doing this. I appreciate it.
Anytime. Thank you.